All right, welcome everybody. This is section 10.2, parametric equations. This is a little different from equations that we've been doing using the X and Y axis. We're still using the X and Y axis with parametric equations, except we have another parameter required, and oftentimes a parameter is time. Over a period of time. But you'll see, we don't always use time. I think there's a problem in the homework where they use slope as the other parameter that you can use. So let's just take a look. This is what we plan on doing today. It shouldn't take that long, it's an hour or so. Sketch the graph of a curve. Using the parametric equations. You're going to see there's nothing really much to this. Eliminating a parameter, finding the parametric equations. If you don't have it, we can still create the parametric equations. And then this bottom one, I'm not going to cover that, but it's in the book, and I'm going to just write down the page. Well, it's page 706 of the book. It's the last page in section 10. The last page in section 10.2, and you can, I don't even think I can say those tautochrome and brachistochrome problems. These are like really, like they say here, classical calculus problems. It's a nice little read going through this, reading this, even if you wanted to look at, talks about a pendulum swing and all that. There's a great YouTube video, some professor, he's not math, he was physics, and he holds this big metal crushing ball to his head. And just as long as he doesn't add any force to the ball, if he just lets this ball go, it's on a pendulum. If he lets the ball go, it'll swing out and then come right back and should almost touch him, but not quite. I mean, unless he added a force to it. If he added a force to it, then it would probably crush his head and kill him. And there's this great video on it. It's really cool. And it deals with this last concept. About a pendulum swing. It's a really good physics video. It's a great class opening that I think he uses at the beginning of the semester. I should have got that link. You could do physics professor swings a pendulum and almost crushes his head or something like that. You might be able to find it. All right, let's keep going. Okay. So this is what we're going to do. Sketch a curve, eliminate the parameter once again, and then we're going to create the parametric equation from some other equation that we have with just X and Y's in it. When sketching by hand, a curve represents a set of parametric equations. We're going to be plotting on the X and Y plane, each of the coordinates. So we're going to find coordinates, the X and Y. I mean, it's just an X and Y axis. And we're going to find the coordinates and we're going to plot these points. But then there's a little extra that we have to do by plotting the resultant points in order of increasing values of T. Then you'll be able to trace and see, they want you to show which way the graph is moving as T increases. So if this was the graph, they want you to show the way it increases. I don't remember ever doing parametric equations in college algebra or even pre-cal, but God, I remember doing them somewhere. I just don't remember doing them in algebra, maybe pre-cal. I don't remember that. So let me know if you've seen these parametric equations once we get going. Let's see. they're really not that difficult. So we're going to sketch this curve, and it tells you the t's are between -2 and 3. Here's what x is, here's what y is. So when we sketch this curve, it's going to look like this. You have a t, then you have the x values, then you have the y values. And t is going to be going from -2 to 3, -2, -1, 0, 1, 2, 3. So there's our t's. Now, to find our x values, you plug in the t values. So here, first, we're going to plug in -2. -2 squared is 4. 4 minus 4 is 0. So x is 0. Then you plug -2 up here into the y value for t. -2 divided by 2 is -1. So y equals -1. Then we plug in the next t value, -1. -1 squared is 1. 1 minus 4 is a -3. For the x value, plug in -1 here, and you get -1/2. Plug in 0, you get -4, and plug in 0, you get 0 here. Plug in 1, you get -3. Plug in 1 here, you get +1/2. Plug in 2, you get 0. Plug in 2, you get 1, and plug in 3. 3 squared is 9. 9 minus 5, 9 minus 4 is 5. Plug 3 here, and you get 3/2. So this is the graphing. So we're going to go to our graph, and we're going to start with the lowest t, and we're going to plot these coordinates right here, 0, -1, 0, -1. It could be about right there, I'd say. X -3, y -1/2 is about right here. And if you see from the first one to the second one, the graph is moving that way. So this is what you want to do with a parametric equation, show where it's going. So next, t0, the coordinate -4 is 0. -4 is 0 would be about right here. Once again, it's going that way. Then -3, 1/2. -3, 1/2 would be about right here. And this is turning. 0, wait, yeah, 0, 1, x is 0. We're doing this one now. X is 0, y is 1. And then finally, x is 5, y is 1.5. And that's what our equation looks like, or that's what our graph would look like. I mean, it's the same thing. If we had this graph here, and we're going to show that, if we had this graph here, I mean, this is what it would look like. But because it's a parametric, we're using parametric equations, we have to show its path. So we're showing its path as it's moving along during a given amount of time. And you always start with the smallest time, the smallest number going up to the largest number. Just graphing. And they go through that whole process for us here. Same thing we just drew. All right, so that's just graphing. So that's all you, I mean, it's pretty simple. There's only one example there. We'll do 2 examples in the homework, but that's just graphing. And you're going to set it, you're going to set your table up like this. Like I said, the lowest t value going up to the highest t value, and these are the coordinates you're plotting. Not too bad. Okay. Now to find the actual, finding a rectangular equation. So we have the parametric equations. We want the equivalent rectangular equation. For that problem we just had, we would like the equivalent rectangular equation. I don't think, this is not the same one that we're doing, but it's okay. Yeah, it is t squared minus 4 and then t over 2. Okay, so what we have to do first, so here's the two parametric equations we just looked at. So the first thing you do is take any one of those equations and solve for t. And it looks like this might be the easiest one. So they solve for t. They multiplied both sides by 2. And they ended up with 2y equals t. And there we go. So solve one of those equations for t. It doesn't matter which one you do. I say do the easiest one. This is what we got. We solved this equation for t, and this is what we got. Then substitute. The second step is substitute it into the other. Substitute this t into the other equation now. We're going to plug it in there, this 2y. Do you see the 2y substitutes into the t? And when we do that, 2 squared is 4, y squared is y squared. And we have an equation. This is the same equation as our parametric equations. It graphs the same way. If you look, this is a parabola, but it's a parabola y squared. So it's a sideways parabola. So it would look something like this. And that's pretty much what our graph looked like, the y squared with the minus 4. So it's a parabola. I think they show this. Did they show this? Once you, why do I keep my gun? So this is the equation. And if you notice, the minus 4 moves the axis 4 places to the left here because we're dealing with y squared, not x squared. And we moved it 4 places. There's 2 and then there's 4 places to the left. So, I mean, well, actually they're going to show the actual equation next, I think. Do they show it? No, they don't. But if it's not just looking at this equation, you don't draw it with the arrows. So this is the way it would look then. So you don't draw it with the arrows, but it's the same equation if I could draw something similar to that. And that's it. You solve, that's basically it. And we'll be doing that a couple of times in the homework. Solve for t, substitute it into the other equation. And then now you have a rectangular equation with an x and a y in it. Now, the only thing they talk to you about and really want to look at is the domain and range of the rectangular equation. They want you to be careful about that. If we look here at this equation, t has to be greater than -1 because we put a -1 in here. -1 plus 1 is 0, square root is 0. You can't have 0 on the bottom of a fraction. You also can't have anything less than -1, like -2. -2 plus 1 is -1. Square root of -1 is not real. So you can't have anything less than -1 in this problem. So there are restrictions to t. T has to be greater than -1. And that will hold restrictions to your x and y values, your domain and range, when you switch it to a rectangular equation. So they're saying when you're doing this parametric equation, just be a little mindset of what the restrictions on T can be. And if there are restrictions, then there's probably restrictions on the domain and range. So if we go back one spot, hang on. If we go back, we have two equations here, two parametric equations. And we have to solve one of them for T. It doesn't matter which one. They go through the process and they're going to solve, I think, the X for T here. In order to solve this for T, you square both sides. If you square both sides, you end up with x squared equals 1 over square root of a square, cancel T plus 1. These two can interchange. T plus 1 equals 1 over x squared. And then take the 1 over. T equals 1 over x squared minus 1. And this is it, but I think they take it a little further and they show this minus 1 can be changed. T equals 1 over x squared. And you can change minus 1 so the denominators match up. A minus 1 is the same thing as x squared over x squared. So this becomes 1 minus x squared over x squared. So they just took it. So, I mean, me personally, I wouldn't mind leaving it like this. They take it a little further, so it's just one fraction. And they change the -1 to x squared over x squared. So I just wanted to show that process because they're going to show it somewhere. There they go. And then they took it one more step. They made the -1 x squared over x squared. So we solve for T. We have T. Now we have to plug this into the other equation. We got it from the x equals. Now we have to plug this into the y equals. And they do that for us here. This is what we got, T equals, we ended up with T equals 1 minus x squared over x squared. So let's just do the algebra here. 1 minus x squared over x squared divided by 1 minus x squared over x squared plus 1. On the bottom, I can change that plus 1 once again, and I'm going to change the colors so you see that. That plus 1, this was a plus 1. I'm changing it to x squared over x squared. So this becomes 1 minus x squared over x squared. Then the top is 1 minus x squared plus x squared. Those two turn to 0, and we're left with 1 over x squared. When you divide by 1 over x squared, you're actually multiplying by x squared over 1. You take the reciprocal of the second fraction. These cancel out, and you're left with 1 minus x squared. So that's what y equals. Y equals 1 minus x squared. All right, so, and we're done. We have our parametric equation, by the way. We have the x equals and the y equals. The parametric equations we had. We have now the rectangular equation, because we have x and y in one equation now. So this is the rectangular equation now. These, the x and the y's were parametric. These are rectangular. And then they're going to just show the graphing part, I believe. When you graph it, this is what we ended up. Well, actually, we didn't end up with that. I'm glad I caught myself. if you look at the arrows, the lowest t value that they used was down here. And as they increase their t values, the graph goes up and it stops. It can't go. Don't forget, this is -1 down here. Remember, t has to be greater than -1. T0, T3, and it stops there. The same thing happened here. If you look, this is the rectangular equation. Now, the only difference between parametric and rectangular is the rectangular doesn't show the direction from lowest to highest, doesn't show the direction that the graph travels. And that's what parametric is used for. It's a lot in space flight. And if you heard the news lately on the Russians blowing up some satellite in space, and their space debris is everywhere. There's mathematicians and physicists out there all over America following all the space junk out there. And it almost, they said it didn't almost hit. It came within a few miles of the space station, and a piece of space junk going, 60,000 miles an hour. If it hits a space station, it's going to destroy some stuff and probably kill some people. So they have to watch this space junk. And things like this parametric equation will help them track and monitor where the space junk's going over time. So now we're going to actually have the rectangular equation and find the parametric equation. You're going to notice that to find the parametric equations, you can oftentimes get more than one answer. And I'm going to show that. You can actually get more than one answer. So here's our rectangular equation. And for a parametric equation, we need two things. We need y equals in respect to t. Let me write that down again. Remember, you need y equals, and I'm just going to write it as a function in respect to t. There has to be a t over here somewhere. And you need x with respect to t. There has to be a t over here somewhere. These are parametric equations. If you go back, if we go back to what we've looked at, we have x with respect to t, and then we also had a y with respect to t. And I'm just doing part A right now. There's two parts of this. Part A. This is really interesting. When you see t equals x, this is a good thing. I'm just going to write good. Because we already said we needed x with respect to t. Well, x equals t. That's one equation. That's one of the parametric equations. X with respect to t. You can write it as a function, and there the t is what we're looking at. Now we have to put y with respect to t. And they don't write it as a function. They just write it y equals. But here's our y equals. And we know that t and x equal each other. So the second, this is the first equation. So the second equation is this one, 1 minus x squared. However, we know t and x equal each other. Part A, it tells us t and x equal each other. So just change the x to t. And we have our two parametric equations, x equals t and y equals 1 minus t squared. That's it. It's really not that bad when x equals t. And even if it's not equal to t, it's not that bad. All righty. And you don't always have to do parametrics with respect to time. They're going to show you the slope at any given point. Let's see what they talk about here. There's A, they just show you once again, what we just talked about in A. X equals T, that's one parametric equation. Then since X equals T, and this equation just change the X to a T, you end up with this, Y equals 1 minus T squared. That's the second equation. There's our two parametric equations. Now the next one, B, we're using the same function, the same rectangular equation, 1 minus x squared. So we want to find y equals 1 minus x squared. So we want to find the slope. The slope is always y prime. So take the derivative of 1 minus x squared and you get 2x. So that's where our slope equals 2x. Now that we have an equation, we have to set it equal. Once again, we have to have x equals something, and it's going to be with respect to m this time instead of t, because we're using m as the parameter. So all you have to do is keep x by itself. So we divide both sides by -2, and you get m over -2 equals x, which is x equals -m over 2, same thing. And then here's our equation. We found this. Now, all we have to do is take x and put -m over 2 into it. Y equals 1 minus x squared, which is a -m over 2. And I'm going to erase all this and show you this there. They go through that, and there's our second equation. So these are our parametric equations for the rectangular equation y equals 1 minus x squared. And do you see this is a parabola up 1, facing down because of the negative in front of it. And if you go through the graphing part with the t and adding all the numbers, you can see here, they show you the direction that it goes up and down. So we're going from, first we went from parametric to rectangular. Now we went from rectangular to parametric. So once again, this is a rectangular equation. These are parametrics, and they give you the same graph, the same shape. And let's take a look at the homework. Wait, was that it? Yes, let's take a look at the homework. I thought I had the homework ready already. Maybe I did. 10.2. So I'll do, I think I'm going to do, there's 8 problems. I think I'm going to do 4. If it lets me. Okay. All right, so let's take a quick look. Let's just, you just have to pick out the correct graph. That's all you have to do here. And then I said, write the corresponding rectangular equation. So let's just go through the graphing part again. Once again, t, x, y. And now the good thing, well, I don't know if this is a good thing, but they don't tell us what the t parameters are. Should we start at 5? Should we start at 0, -2? You know, they don't tell us what the t parameters are here. If you look, there really are no restrictions to the domain of t, or domain or range, or domain or range of t. Doesn't look like there's any restrictions. So we can just start, let's just start plugging some numbers in there. Let's start with something negative. I don't know. Let's go crazy. Let's start with a -3 and see what we get. If I put a -3 in here, 5 times -3 is -15, -2 is -17. Put a -3 in here, I get -6 plus 1, I get 5. So we need to graph -17, 5. -17, 5, -17, 5 would be, this looks like it could be it, you know. This is definitely not it. -17, 5 is somewhere here in quadrant 2. This doesn't have a graph in quadrant 2 at -17. It could be this one, and it cannot be this one. So it's one of these two graphs. Let's get a little closer. So we said -3. How about 0? Let's start at 0, see what happens. If I put a t0, put a 0 in here, x is -2, put a 0 in here, y is 1. So I get -2 and 1. That didn't look right. Did I do that right? If t is 0, x is -2. If t is 0 here, y is 1. -2, 1. Well, maybe I did something wrong on the first one, because I see a -2, 1 over here. -2, 1, it looks like there's one right here. -2, 1, it could be this one. What happened to the first one? -3. And, oh, this, I typed it, -3 is not 5, -3 and -5. -3 plus 1 is -5. I had the wrong number in there. So, -17, -5. This can't be a possible answer. -17 and -5. This could be an answer. This could be an answer. This cannot be an answer. These two cannot be an answer. So it's one of these two, and we do have dots on each one that we said. So I'm going to keep on going. And I'm going to 1 now. I started it, I had that dot at 0. Now I'm going to put a 1 in there. So it's not a blatantly obvious, and we already said that. So I'm going to put a 1 in here. 5 minus 2 is 3. And put a 1 in here. 2 plus 1 is 3. So we have 3, 3. So 3, 3. Let's call it about right there. 3, 3, call it about right there. And if you look, 0 was here. T equals 0 was here. T equals 1 is here. T equals 0 is here. T equals 1 is here. So the graph is going this way. From here to here, it's going this way. If you look, that one matched up. This one is going the opposite direction, so that's not correct. As the T's are getting larger, that's the direction you have to be going. So we went from 0 to 1. The arrow has to be going towards the 1 then. The arrow has to be going towards the 1. So that bottom left one looks like the correct answer. That's the one I think we picked. Yes, it is. All right, so now I'm going to come back. Now we have to create the parametric equation from this. And don't forget, we have these two. The steps for creating the parametric equation was solve for t. Step one, solve one of the equations for t. It doesn't matter which one I do. I'm going to do the first one, x equals 5t minus 2. Take the 2 to the other side. Divide by 5. And there is the first t equals, except I think I did, this is a minus, so you have to add 2 to both sides. So that should be a plus. All right. Okay, so there's 1. Now I take this and plug it into the other equation. The other equation is this y. Y equals 2t plus 1. Step 2 was take the answer from step 1, plug into the other equation. And so now I need to do y equals 2 times t plus 1, and t is x plus 2 over 5, which become distribute 2x plus 4 over 5 plus 1. I mean, this definitely doesn't look like an equation that we want. I'm assuming, I would think they want us to keep this all in one fraction or whatever. So just like I did before, it's so easy to change a 1 to a common denominator. 1, since our common denominator is 5, we can change that 1 to 5 over 5. And we have 2x plus 4 plus 5. I get y equals 2x plus 9 over 5. Multiply both sides by 5. Get rid of that 5 on the bottom. And I'm left with 5y equals 2x plus 9. I mean, I'm happy with this. They just bring it all. They didn't say what form to bring it into, like standard form where x has to be positive. So if you bring it over to standard form, the 5y comes to the other side and you get 0 equals 2x minus 5y plus 9. And that's what they ended up with. This is the rectangular equation. So you're solving one equation for t, you're plugging it into the other one, then you have your x and y, and just whatever form that you want. I mean, I'm saying that I think you could have, let's say, I'm going to see, this is the answer they got. Let me type this in and see if they recognize it. 5y equals 2x plus 9. Let me see. I'm assuming they're going to say that's the correct equation. I mean, it shouldn't matter what form they want it in unless they tell you specifically to put it in a certain form. 2x plus 9. It shouldn't matter. And I'm going to clear all the drawings, and I am going to hit enter or submit and see if it marks it correct or wrong. I thought I hit it. Oh, there it goes. And it looks like it marked it wrong. Which one did I do? Oh, there it is. Your answer cannot be understood or graded. Well, let me see what form they say. Sketch the parameter, include the orientation curve, and write the corresponding rectangular equation by eliminating the parameter. So they didn't, Oh, it's y equals. They want it in the form of, see, I didn't even see that. I thought this was their answer, but that's not correct. The answer is in the form of y equals. So we just, it's 2x plus 9 over 5. Let's redo that. 2x plus 9 over 5. The fraction, 2x plus 9 over 5. I didn't even see the y equals there. I thought they just wanted to write the equation in. Now let's see if they take that. They should. You would think they would have. Yeah, that looks like they took that one. I think. Yeah. So be careful. I mean, I was assuming that, I mean, this, and to show your work, this is fine for me right here. But they wanted it y equals. They wanted it in a certain form so they could mark it right or wrong for you. All right, let's try another one. Sketch the curve and the graph once again. We're going to do t, x, y. And they don't give us any parameters for t. So like I said, you can try pretty much anything you want. Let's try, if you look up here, if you put a -5 in here for t, then x is 0. So I'm going to start off by putting a -5 in there. So -5 plus 5 gives me x 0. If I put a -5 up here, -5 squared is a positive 25. So 0, 25, 0, 25 is way up here, way up here, way up here, way up here. And pretty much all of them could satisfy that. So let's try a smaller, let's try -2. Or yeah, well, now let's try t equals -3, something smaller, -3. Put a -3 here, -3 plus 5, x equals 2. Put a -3 here, y equals 9. -3 squared is 9. So 2, 9 would be about right here. 2, 9 would be about right here. 2, 9 would be about right here. That don't look correct. 2, 9 would be about right here, unless I got a sign wrong again. So if I put a -3, and so that changes, x is 2, put a -3 here, x is 9. So it's one of these two is correct. Now, if we look, we went from way up here to down here. So our graph should be going, this is -5, -3. As we're getting larger, the graph is going this way. So the graph is, as we said, was from up here to here, is going this way. So it looks like the first one is the correct answer because the arrows are going that way. This one, the arrow is going the wrong way, it looks like. So the correct answer looks like A. And I think that's A, yes. Okay. So now we got to find the rectangular equation. Take one of the equations and solve for t. Let's take the first one. X equals t plus 5. Just take the 5 to the other side. Then we plug this into the other equation. The other equation was y equals t squared. And so y equals x minus 5 squared. And there's our answer. I mean, Once you plug it back in, you have one equation with X and Y in it. That's our rectangular equation. X minus 5 raised to the second power. And I think we got that one correct also. Oh, we didn't pick the correct graph though, but I mean, we picked the correct graph, we just didn't mark it. So that is the correct equation. So that's not too bad. Graphing those, I mean, the only thing you have to look at is where the t's go from smaller to greater. You know, they're from the left side to the right, which direction the graph is going. So you want to try to keep, just don't pick numbers at random. You can at first to see if it's anywhere close to your graph. But then if you get close, if you're on the graph, then you want to pick another higher number so you know the graph is going which direction. All right, and there's some more things on here to do, but I want to go down to the bottom two questions. Here we go. So 7. It says, find a set of parametric equations for the rectangular equations that satisfy the given condition. So here's the rectangular equation. It says t equals 0 at this point, 2, 5. Once again, this is the x and this is the y. And if you put a 0, or if you put a 2 into the x, you see y does equal 5. If you put a 2 into the x, y does equal 5. I always check that out to make sure it's okay. Now this is a little tricky here, just a little tricky. It says at t equals 0, we need an x equation. We need an x equation. But don't forget, we need the x equation with respect to t. So we need a t in here somewhere. We need a t in this equation somewhere. And I'm just going to put a t in here. But we know when t is 0, at t equals 0, there is a point. X has to equal 2. So I'm putting a 2 here. And if I just put a plus sign here, do you see? I just created this equation on my own. At t equals 0, if I put a 0 here, then x equals 2. That's what I wanted. At t equals 0, x equals 2. Now, this is my equation. I want to show you, though, they came up with a different equation. But that's okay. I've already mentioned this. When you have a rectangular equation, you can have multiple parametric equations that graph the exact same thing. So instead of x minus t, 2 minus t, I'm going to use 2 plus t to show you that this is okay to have also. You can plug, if I plug a 0 in here, I still get x equals 2. That's what I wanted, x equals 2. So it doesn't matter the 2 plus t or 2 minus t. It doesn't matter. They both will work. So that's the first thing I do. Then I need to plug this in to the other equation, so we plug that, we had the x. Now I need the y equals 3. And then once again, the y parametric equation has to be with respect to t. 3 times x plus 1, but we have to have it with respect to t, x equals 2 plus t. Distribute. Plus 1. Then 6 plus 1 is 7. Right? Wait, why
is it a plus 1?
Say it, oh, it's minus 1. Thank you. Thank you. It's supposed to be -1. So we end up with y equals 5 plus 3t. And there's our parametric equations. X equals 2 plus t. And if you notice, it says enter your answers with a comma separated. So, I mean, they got a little bit different. They got, if you look, they got these two. They got this equation, and then they got y equals this equation. So it's different from mine. Let's see when I type mine in. But you can have multiple answers. One answer is x equals 2 plus t. And then it says separate your answers with a comma. The other answer is y equals 5 plus 3t. And we're going to check that work. And if we go down to number 7, you see they marked it correct. So it didn't matter if I picked 2 plus t or 2 minus t. It doesn't matter because there's more than one solution for parametric equations. Once again, you could have plugged in x equals 2 minus t as one equation. I shouldn't have put parentheses around it. And then y equals -3t plus 5 as the second equation. And you would have got it correct also. That's what they ended up with. They ended up with this. So it didn't matter which one you plugged in. That's not a bad thing. Number 8, let's take a look at number 8 down here. Y equals x squared and t equals 8 at this given point. So this is really easy, but it's kind of hard if you've done it for the first time and you don't get the help that's in this homework solutions thing. If you look at this, the previous problem, it said t equals 0 at this point. So when t equals 0, x equals 2. So you had to have an x equals 2 somewhere plus a t or a minus a t when it equals 0. However, look at this. T equals 8 and x equals 8. In other words, t equals x. What they're saying, t and x at this point equal each other. So that's one of the parametric equations. The other one, I mean, we have that already. Now the other one is take t. Now we're substituting in here. The other equation, y equals x squared, but we have to make it in respect to t. If x equals t, then you just substitute it in there. So y equals t squared. That's the second equation. So one equation is x equals t. X equals, it's really nice and easy when x equals t. And the other equation was y equals t squared. And what's good, these have watchets also. But I mean, it's really, once you have that process down, it's not that difficult. It's not that difficult. I mean, we still have a few more sections in chapter 10 to cover, but that's it, the parametric equations. All right, let me hit stop.